Hello, in this video we will prove sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. In the previous video we proved cosine of alpha plus beta equals this value. Okay, since we have proved this thing, so that means we can use this to prove this thing. Okay, so we have to prove this is equal to this. So we take this value and we will prove this is equal to right hand side. So here is the proof, a very short proof of this formula. Since sine of any angle equals cosine of 90 minus this angle. Because sine and cosine are 90 degrees away, that means if I subtract angle from 90 and apply cosine is the same as applying sine on the same angle without subtracting from 90. The same is the case if you have cosine of some angle, for example alpha plus beta, which is so this is also equal to sine of 90 degrees minus the same angle. So they are 90 degrees away from each other, we can say. So this is equal to this value, right? Now I can write cosine of 90 degrees minus alpha minus beta. I can write it as cosine of 90 plus alpha plus minus beta. Okay, now I think, sorry, here I should write 9e minus alpha minus beta. Minus beta means plus minus beta is the same thing. Okay, so if you assume cosine of this whole thing is alpha and this whole thing is beta, then I have previous formula. What is this formula? This formula says cosine of two angles, cosine of the sum of two angles equals this. Since this is from previous formula, since we have already proved it, here alpha refers to this angle and beta refers to this angle. So that means here alpha is this angle, beta is this angle, alpha is this one and beta is this one. So I can apply this whole thing on this formula. How can I apply? So we have this whole thing equals to cosine of alpha plus beta, which is equal to cosine of alpha cosine of beta. So I should write cosine of alpha. What is our alpha? Our alpha refers to this thing, 9e minus alpha. 9e minus alpha. Okay, times cosine of beta. Cosine, what is our beta? Our beta is negative beta. So I'll write cosine of negative beta. Then I have minus sine of alpha. So I'll write sine of, what is our alpha? Our alpha is 9e minus alpha times sine of beta. I'll write sine of, what is our beta? Our beta is negative beta. So I'll write negative beta. Okay, since as I mentioned previously, cosine of 90 minus alpha is actually sine of alpha, because both sine and cosine are 90 degrees away, and cosine of negative angle is cosine of the angle without negative minus, again sine of 90 minus alpha is cosine of alpha. So I'll write cosine of alpha, And sine of negative angle is the negative of the sine of the angle. So I'll write negative sine of beta, which is equal to sine alpha cosine beta. This minus will kill this minus. It will become plus cosine of alpha and sine of beta. So I have proved this thing. This is equal to, the left hand side is sine of alpha plus beta. So I have proved this formula. So it's very easy trick to find this, to prove this formula, because we already know this formula. We have already proven it. So this proof is short and easy. Okay, once we have proved it, now I will prove that tangent of the alpha plus beta equals this whole thing. Okay, so we need tangent of alpha plus beta equals this. So we take this side, left hand side, which is tangent of alpha plus beta, because if we have to prove some equation, we take left hand side and we prove that the right hand side is also the same. Okay, we prove the right hand side. Okay, so we take the left hand side. Since you know tangent of the angle, any angle, is equal to sine of the angle over cosine of the same angle. So here, instead of theta, I have alpha plus beta. So I'll write, using this formula, I'll write sine of alpha plus beta equals divided by cosine of alpha plus beta, right? Since I know what is sine of alpha plus beta, I know what is cosine of alpha plus beta, because I have already found their formulas. So I will use their formulas, which I have already proved. Since sine of alpha plus beta equals this thing, so I will write this thing over there. In place of sine of alpha plus beta here, I'll write this value. And cosine of alpha plus beta is this one. So I will write this value over there. So what I have done, I have plugged their values. Okay, now what is the right hand side? Right hand side involves sine and cosine, but I need right hand side to be only in tangent, right? So tangent can only be achieved if everything is divided by cosine, because if we divide everything by cosine, then I can get tangent, because in the numerator I have sine here, right? For this sine and for this sine, I have to divide by cosine of alpha and cosine of beta. Then I'll get everything in tangent. So I will divide up and down by cosine of alpha and cosine of beta, right? So I'll write divide up and down. Okay, so I will divide by this number both of the terms, up and down, right? So this is upper term. I have to divide it by some number. How can I divide it by some number? Divide by, the number is cosine of alpha, cosine of beta. And similarly, I have to divide down by the same number, which is cosine of alpha, cosine of beta. Okay, what will I do now? I will distribute this thing to this thing and then to this thing. Okay, so I'll make two terms. Let's look how. So look, I have to distribute this to both of the terms. So how can I do that? I can write this thing divided by this whole thing here, and this thing divided by this whole thing. Okay, in this way you can distribute one term to both of the terms, right? Because the denominator is for both, is common for both, so I can write this way. Similarly, I can write this way, this denominator here and the same denominator here, because it was the common denominator, so I can distribute the denominator to both. Here, look, cosine of beta will be killed by cosine of beta. Here, cosine of alpha is killed by cosine of alpha. Here, cosine of beta is killed by this. Here, sine, here nothing is killed. But here, cosine of alpha is also killed by cosine of alpha. What I left? Here, I will left sine alpha by cos alpha. I told you sine over cos is tangent. So I have this thing equals to tangent of alpha, and this thing equals to tangent of beta, here everything is cancelled, so I will write 1 minus sine of alpha over cosine of alpha is tangent of alpha, sine of beta over cosine of beta is tangent of beta, which is the right hand side, because this is what you had to prove. Okay, you can check, this is what you had to prove. So you took left hand side here and you made the right hand side. That means you are done. Okay, now we prove that cosine of alpha minus beta is equal to this thing, sine of alpha minus beta is equal to this thing, and tangent of alpha minus beta is equal to this thing. Since previously we have proved everything for alpha plus beta, this one, everything for alpha plus beta, this time we prove the same thing for alpha minus beta. Okay, so here is the very short proof. For each of the proof we will need the similar trigonometric function but with plus. So in order to prove a part, we need cosine of alpha plus beta, because we know what is cosine of alpha plus beta. Since cosine of alpha plus beta equals cosine of alpha plus beta minus sine of alpha sine beta. Okay, so this is we already know because we have already proven, but we need cosine of alpha minus beta. What will we do? We replace beta with minus beta. What will happen? The left hand side will become alpha. Since I am replacing beta by minus beta, so this will become alpha minus beta. Cosine of alpha is as it is, but I am replacing beta by minus beta. So cosine of minus beta, sine of alpha, I am replacing beta by minus beta. So this is alpha minus beta. Cosine of alpha as it is, You know cosine of negative angle is the same thing. I mean cosine of negative angle is cosine of that angle. So I have cosine of beta, but sine of negative angle is the negative of sine of the angle. Okay, so negative of the sine of the angle. Okay, since this minus will kill this minus, so it will turn into plus. Cosine of alpha, cosine of beta plus sine of alpha, sine of beta. So this is done. Now we do the B part. In the B part, we need to find sine of alpha minus beta. Since sine of alpha plus beta is equal to this thing, so we will again replace beta by minus beta. So I'll write sine of alpha plus minus beta equals sine of alpha cosine of minus beta plus cosine of alpha sine of minus beta, because I have replaced beta by minus beta everywhere, right? Now if I simplify, I have sine of alpha minus beta equals sine of alpha. Since cosine of the negative angle is the cosine of the angle, I mean no change, but sine of the negative angle is the negative of the sine of the positive angle. This sine, this negative will kill this positive, it will turn into negative. So sine of alpha cosine of beta minus cosine of alpha sine of beta. So this is what we had to prove in B part. Now in C part we had to prove the same thing for the tangent. Okay, so we will write tangent of alpha plus beta, which we have already proved, but we have to prove tangent of alpha minus beta. So we will again replace beta by minus beta. So if I replace beta by minus beta, I'll get alpha plus minus beta equals the same thing, tangent of alpha plus tangent of minus beta over 1 minus tangent of alpha times tangent of minus beta. Here tangent of alpha as it is, but you know tangent of the negative angle is the negative of the tangent of the positive, negative of the tangent of the positive angle over 1 minus tangent as it is, but again tangent of the negative angle is the negative of the tangent of the positive. Here I have tangent of alpha minus tangent of beta over 1. This minus will kill this minus. I have 1 plus tangent of alpha tangent of beta, and here I have tangent of alpha minus beta. So this is what we had to prove. So we are done. So in short, in this video and the previous video, we have proved 6 different formulas: cosine of alpha plus beta, sine of alpha plus beta, tangent of alpha plus beta, different formula. Then the same 3 formulas with negative, this and this. So you have to memorize these formulas to solve the next coming questions. So the question is, in this question we have sine of alpha, sine of beta, cosine of alpha, cosine of beta. We have to find this value. Okay, since we have to find this value, so we need to use its formula. So if we use its formula, sine of alpha plus beta equals sine of alpha cosine beta plus cosine alpha sine of beta. Okay, since sine of alpha is given, which is negative 21 square root by 5, so negative 21 square root by 5 times cosine of beta is also given, which is 4 by 5 times 4 by 5 plus cosine of alpha is 2 by 5 times sine of beta is 3 by 5. Okay, so if we calculate these values, we'll get 25 times negative 4 square root 21 plus 6. Okay, so this is the result for this. If we find cosine of alpha plus beta, since its formula is this one, if we plug the values, cosine of alpha times cosine of beta, which is this times this, 2 by 5, 4 by 5, let me write 2 by 5 times 4 by 5 minus sine of alpha times sine of beta means this times this, negative, I should write negative, one more negative, that negative will kill this negative, 25 by 5 times 3 by 5. Okay, now if I calculate these values, we will get 25 on the denominator, 8 here plus 3 times square root 21. Okay, now if I find the value of tangent of alpha plus beta, so this formula is equal to this thing. So if I plug the values, but I don't have tangent of alpha, tangent of beta, so how can I find tangent of alpha and tangent of beta from here, from this data? I can get tangent of alpha is sine alpha over cosine alpha. Since sine alpha is negative square root of 21 by 5 and cosine of alpha is 2 by 5, I can cancel this 5 with this 5. My tangent alpha will become negative 21 by 2. And similarly, I can find tangent of beta, right? So if I find tangent of beta, this is equal to sine beta over cosine of beta. Sine beta is 3 by 5 and cosine beta is 4 by 5. This 5 is cancelled with this 5, so the answer is 3 by 4. Okay, so tangent alpha is square root 21 over 2 and tangent beta is 3 by 4. So here I'll plug negative square root of 21 by 4, 2 plus tangent of beta is 3 by 4 divided by 1 minus tangent of alpha again, this value, but this is negative. This negative will kill this negative. Now you check that the denominator for both is not common, so you have to make this common. This is 4, you can make it 4 also by multiplying and dividing by 2. How can I do that? I can write negative 2 times square root of 21 over 2 times 2. I have multiplied and divided by 2 plus 3 by 4, and here I have 1. Okay, I can multiply. Okay, let's check. You have two different terms. In the first term, the denominator is 1. I mean, you can write 1 by 1, and here the denominator is 8. So you can make the denominator 8 here also by multiplying and dividing by 8. So this term is 3 square root of 21 divided by 8. So here this term is 4, this term is 4, so that you can write the common denominator, which is 4, and here negative 2 times square root of 21 plus 3 divided by, both terms again have the same denominator. You can write 8 as a common denominator. 8 plus 3 times square root of 21. Okay, you can write this term in this way: negative 2 square root of 21 plus 3 divided by 4. This whole, division, you can write in this way: 8 plus 3 square root of 21 by 8. Now you can write this whole thing as it is here, but if you turn this division with multiplication, then this comes down and this term comes up. You can write 8 divided by 8 plus 3 times square root of 21. 1 times, 4 2 times, so you can write this 2 multiply with this one. If I multiply 2 with this negative 2, I will get negative 4 times square root of 21. Then if I multiply this 2 with 3, I will get 2 times 3, which is 6. And down I will have 8 plus 3 times square root of 21. So this is the answer, right? Now we have to find sine of alpha minus beta. Since sine of alpha minus beta is this thing, so here we can plug their values, but in the center we have minus instead of plus as previously we had. Okay, so if I solve this, the denominator of this is 25, the denominator of this is 25, which is the common denominator for both. So I can write 25 here, and here negative 4 times 21 square root minus 6. So this is your answer. If you are going to find cosine of alpha plus minus beta, so you will get this value, because this is the formula, and then in the formula I plug the values as they were given. Again, this is 25, this is 25, So I can write the common denominator, which is 25, and here I have 2 times 4, which is 6, minus 3 times square root of 21. This is the answer, right? Now, in order to find tangent of alpha minus beta,